Okay, let's look a little bit at how oceanography continues now in the modern ages, following all those historic voyages from a couple of centuries ago. So obviously there is much more high technological tools available now. We have sonars, we have robotics, we have computers, we have lots of satellites, and we have, of course, GPS and so on, which make it very easy to navigate the oceans north, south, find your location, and so on. So I won't go into too many details, but you can easily go online and find all the satellites that are looking at the ocean, all the instruments that are moored in the ocean permanently, or gliders that are going around, autonomous buoys, robots that go up and down, that use wave energy, solar energy, gravity, and so on and so forth. Incredibly exciting work goes on in oceanography, of course. It's become a major discipline of science, of course, because for global warming, we know that ocean keeps 90% of or takes up more than 90% of the energy from the anthropogenic activities, or energy trapped because of increases in greenhouse gases created by human activities. So what is the nature of scientific inquiry? Along the way, usually in the olden days, people used to basically record what they observed, and then the natural phenomena that were governed by physical processes would have to be understood. So once you have some information, some data, whether it's celestial, astrophysical data, or natural vegetation, ecological data, properties of the atmosphere, the ocean, the land, and so on, the processes that are functional today are essentially the same ones that were functional in the past. The so-called uniformitarian principle becomes very critical for interpreting past data, but also we have chemical evidences, geological evidences, biological evidences to tell us how these functions have worked over time. Of course, there are other details that we'll come back to later on in terms of how quickly the ocean was affecting the atmosphere and the atmosphere was affecting the ocean, or the so-called coupling coefficient, or the climate sensitivity, and so on. These can change over time. There are ways to estimate that. There are problems with estimating that, of course. Again, that becomes important for global warming calculations. So essentially, scientists want to discover these processes, the so-called process understanding, and they want to make predictions from understanding those processes. So they also want to increase predictive understanding, because if you want to plan for global warming into the future, you want to be able to predict and project what will happen in the future. This is broadly referred to as the scientific method, or the scientific inquiry. So you get some observations, you build a hypothesis based on the observations you collected, then you test the hypothesis by collecting more observations, and after repeating the process, you convince yourself that the hypothesis can be now proposed as a theory. So science does not actually prove things in that sense. It builds theories based on hypotheses which are based on observations, and then you keep looking for evidences that will confirm the theory, or you might find that there are exceptions to the theory. Then you have to understand why in some cases the theory may not work. So that's essentially how science works. So theories and truth, people tend to kind of confuse. Science is not about absolute truth. It's about finding data that confirms a theory that you have built based on empirical evidences. Truth is probable and based on available observations. So the grand exception, of course, is that Einstein proposed, for example, theory of gravity, relativity, and so on, for which we still look for data to confirm his theories. New observations are essential for advancing our understanding. For example, the feedbacks between the ocean and the atmosphere, between the phytoplankton and the atmosphere, and so on. And in reality, scientists cannot have like a blueprint for everything. So best is always to make observations, look at them carefully and see what process is operational, build a hypothesis, test the hypothesis by collecting more observations, and then that should lead to a theory.